science, we see the threat, and we know the time for action is now. Now, it's not every day you get to agree with a politician, so this was a pretty happy day for me. And I thought that it was kind of a turning point. It seemed as if it was kind of a turning point for a Republican governor to make a statement like that. And also because public opinion polls seem to indicate that the American people agreed. A major poll done by the Gallup polling organization in 2007 showed that 72% of American citizens were mostly or completely convinced that anthropogenic global warming was underway. Indeed, 62% of U.S. citizens, when polled, said that they believed that life on Earth would continue without major disruptions only if society takes immediate action to reduce global warming. And indeed, at that time, even many former skeptics and contrarians had come around. So one particularly notable one was Frank Luntz, a Republican strategist, who in 2006 in an interview said, "It's now 2006. So he was off to a good start. He got the year right. And he said, "I think most people would conclude that there is global warming taking place and the behavior of humans is affecting the climate." Now, Luntz was important historically because he was famous, some might say infamous, because he was the author of a memo to Republican candidates running for public office in the United States in which he advised Republican candidates not to use the phrase global warming, but to talk about climate change instead. And the reason he argued was because climate change is a lot less frightening than global warming. And if people were frightened, they would demand government action. So in order to avoid government action, it was important not to allow people to be frightened. And he said that the way to do this was to insist that on the scientific uncertainty, to emphasize scientific uncertainty, and to insist that there was no scientific consensus on the issue. And so he wrote in a very long memo with a section to Winning the Global Warming Debate, an overview. He wrote, and all of the emphasis here is his own, "The scientific debate remains open. Voters believe there is no consensus about global warming within the scientific community. Should the public come to believe that the scientific issues are settled, their views about global warming will change accordingly. Therefore, you need to continue to make the lack of scientific certainty a primary issue in the debate." So if I had to summarize my story in a nutshell, or if any of you need to leave right now, this is the essence of the story: how scientific uncertainty became a political tool to prevent government action on global warming. Now, as a historian, I can ask the question, was Luntz's position factually correct? Was it true that the scientific debate remained open? And the short answer to that question is no. In 2001, the Intergovernmental Panel on Climate Change, the world's leading organization of scientific researchers who do research and collect data on the question of climate change, had stated unequivocally that human activities are modifying the concentration of atmospheric constituents that absorb or scatter radiant energy. Most of the observed warming over the last 50 years is likely to have been due to the increase in greenhouse gas concentrations. So that's a pretty clear statement of where the bulk of scientific opinion lay in 2001. But in fact, the scientific consensus had coalesced even earlier. In 1995, in the second assessment report of the IPCC, scientific experts had concluded that the balance of evidence suggests a discernible human impact on global climate. Now, in the early 2000s, I had become interested in whether or not these summaries were an accurate reflection of what was published in the peer-reviewed scientific literature. Because any historian or sociologist knows that, or any citizen knows, that just because the leadership of an organization says something doesn't prove that the rank and file agree with it. So I was interested in testing the hypothesis of whether or not the rank and file scientific community agreed with these consensus statements. And the short answer was yes. In fact, they agreed even far more than I had imagined possible. So in my own analysis of the peer-reviewed published scientific literature using the Institute for Scientific Information database, I discovered that scientists had an expert consensus on the reality of human-caused climate change by the early 2000s. And in fact, when we posed the question, how many articles published in peer-reviewed journals disagree with that consensus statement that I just quoted to you a minute ago, the answer was none. Not a single one. So that was a surprising result. It surprised a lot of people. It surprised me. But honestly, we shouldn't have been surprised by this result. I shouldn't have been surprised by this result. Because, of course, the United States is a signatory to the UN Framework Convention on Climate Change. And the UN Framework Convention on Climate change, signed by our first President Bush, George H.W. Bush, in 1992, was a reflection of the fact that the scientific community had already concluded that the world was at risk of dangerous anthropogenic interference in the climate system. So the Framework Convention, to which there are 193 signatories, commits the world to taking action to preventing that dangerous anthropogenic interference. And when President George H.W. Bush signed the Framework Convention on Climate Change, he called on world leaders to translate the written document into concrete action to protect the planet. So what happened? Why didn't we take those concrete steps that President George H.W. Bush promised? Why didn't we act to do something about this issue that even Lyndon Johnson knew about in 1965? So this essentially is the question that our book, and I want to acknowledge the work of my co-author, Eric Conway, this is the question that our book tries to answer. What happened? Why, given that we had a scientific consensus on this question as early as 1992, why haven't we taken concrete steps to protect the planet? So what I'd like to do tonight then is to give you a very, very abbreviated history of the evolution of climate science. If you're interested, there's much more detail in the book. And then to tell the story of the emergence of a challenge to that science. A challenge that was based not on scientific issues, but on political motivations. A story of selling uncertainty, of using scientific uncertainty as a political tool, and of emphasizing doubt, motivated not by epistemic concerns, not by a principled anxiety about data or theories or models, but by a doctrinaire belief in free markets, in the power of free markets, and born and hardened in the Cold War. So the story begins in the 1850s with the work of this scientist, John Tyndall, who first established what it means for something to be a greenhouse gas. In a series of experiments, John Tyndall showed that certain gases, most notably water vapor and carbon dioxide, have a very important property of being highly transparent to visible light, but relatively opaque to infrared. So light from the sun penetrates the Earth's atmosphere, but heat that is re-radiated back out to space tends to get trapped. And Tyndall recognized that this was a very important and good thing about the Earth, because without greenhouse gases in our atmosphere, the Earth would be as cold as the Moon or Mars and quite inhospitable for life. Now, in the early part of the 20th century, the Swedish geochemist Svante Arrhenius took up this question and realized that when you burn fossil fuels, you produce greenhouse gases, carbon dioxide, as a byproduct. And therefore, the burning of fossil fuels, such as coal, could lead to the amount of carbon dioxide in the atmosphere increasing, and this could change the climate of the planet. It could warm the planet. Arrhenius did the first calculations of what would happen if we doubled the concentration of carbon dioxide in the atmosphere, and he concluded that it would increase the average temperature of the globe between 1.5 and 4.5 degrees Celsius. Now, Arrhenius was Swedish, so he thought global warming would be a good thing. The first person to suggest that it might be a bad thing, and that it might in fact already be underway, was the British steam engineer Guy Stewart Callendar, who in 1938 published the first article in a peer-reviewed scientific journal suggesting that climate change caused by increased greenhouse gases was actually already occurring. Now, that was 1938. The following year, war broke out in Europe. Callendar went to work on war work, and scientists essentially dropped this issue for a number of years. Moreover, there was one very major uncertainty that called into question Arrhenius and Callendar's calculations, and that was the effect of water vapor. So Tyndall had showed that water vapor is also a powerful greenhouse gas, and we all know there's a lot more water vapor in the atmosphere than there is carbon dioxide. So some people argued that small increases in carbon dioxide would have no real effect because they would be swamped by the much greater effect of water vapor. And this is an argument that we still hear today, propagated by some climate skeptics. Well, this issue was taken up in the early 1950s by this man, Gilbert Plass, who was one of the pioneers of upper atmosphere spectroscopy. In a series of experiments, Plass was able to resolve the absorption spectra of water vapor and carbon dioxide, and show that the area of the infrared spectrum that is heavily absorbed by water vapor is different from and distinct from the areas of the dominant carbon dioxide absorption spectra. And this meant that if you added more CO2 to the atmosphere, it would have an impact on the climate, and that impact would not be overwhelmed by water vapor. Well, Plass's Science's work had a big impact on two oceanographers working at the University of California, Hans Suess and Roger Revelle. Suess and Revelle took up Plass's work and began to argue that given what he had shown, that the increasing amount of carbon dioxide in the atmosphere would be likely to have an impact on climate, and that therefore mankind was performing a great geophysical experiment. By returning to the atmosphere carbon dioxide that had been stored in rocks in the form of fossil fuels over the course of hundreds of millions of years of geological history. And we were returning that stored carbon dioxide rather rapidly. And so they argued that it would be important for scientists to begin to monitor carbon dioxide in the atmosphere and to monitor the climate to see what effect, if any, that increase in carbon dioxide was having. And Revelle was on the Planning Commission for the International Geophysical Year, and so as part of the planning for the IGY, he argued for and got the funding to support the beginning of a carbon dioxide monitoring program. And that carbon dioxide monitoring became the life's work of this man, Charles David Keeling, also a professor at the University of California. In 1958, as part of the International Geophysical Year, Dave Keeling began what became his life's work, the systematic measurement of carbon dioxide in the Earth's atmosphere. Within a very short period of time, by 1965, Dave Keeling had become convinced by his own data that indeed carbon dioxide was increasing, and that just from 1958 to 1965 alone, it had increased from about 315 parts per million to about 320. Today we're up here at about 390. So it was this work, this early detection, that led then Revelle and Keeling to write a report for the President's Science Advisory Committee, in which they said the following: by the year 2000, there will be about 25% more carbon dioxide in our atmosphere than at present, and this will modify the heat balance of the atmosphere to such an extent that marked changes in climate could occur. And it was this report that reached the desk of President Lyndon Johnson, who, as Professor Peterson already noted, then said in a special message to Congress, "This generation has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels." So as early as 1965, scientists had already established that the chemistry of the atmosphere was changing, that the cause of it was burning fossil fuels, and at least one person in a position of power got that message. Now, in the frontispiece of the book, we have two quotations. This is one of them. The second is a quotation from Adlai Stevenson, who says, "The problem with Americans is that they haven't read the minutes of the previous meeting." And that really sums up our story, because in a way, this message got forgotten. In 1965, President Johnson had quite a few other things to worry about, one of which was tobacco, which we, of course, talk about in our book. And so not much serious attention was paid to this issue in policy circles. But that began to change in the 1970s with the rise of numerical simulation modeling. The development of fast digital computers made it possible for the first time to build effective general circulation models, computer models of the Earth's atmosphere, and to study the Earth's climate as a system. It became possible then to model the dynamics of the atmosphere in a quasi-realistic way, and for scientists to begin to answer questions about long-term trends. That is to say, not just the 5-day forecasting of weather models, but the long-term dynamical effects of things like doubling carbon dioxide. So it became possible then to revisit what came to be known among scientists as the calendar question. And state-of-the-art models built at this time confirmed Callendar and Arrhenius' earlier calculations. And this then led to the beginning of serious policy discussions in the United States and elsewhere at this time. A whole series of different reports were written by various different scientific agencies and organizations. I just summarized three major ones that were influential in the United States. There were several other published in Europe by the World Meteorological Association and other organizations. And they were summarized by the U.S. National Academy of Sciences in a report to the Carter White House in 1979. The National Academy of Sciences put it this way: "A plethora of studies from diverse sources indicates a consensus that climate changes will result from man's combustion of fossil fuels and changes in land use." So by 1979, there was a consensus among scientific experts that climate change would result from burning fossil fuels and changes in land use, mainly deforestation. That is to say,